everyone. This is Aftab Siddiqui. I work for Internet Society as part of the Manners team. So today we will be talking about a small observation I have seen in last few years. So I just wanted to share with everyone that why this benign problem can create a bigger issue moving forward. So the topic is, it wasn't a hijack. So let's see what wasn't a hijack. If you're joining this session, I'm pretty sure it's not new to you that there is a problem with the BGP. And the problem is that people don't secure it properly. It's not that the BGP inherently is insecure. There are measures available, but the network operators don't put those measures in place to make it secure. Attacks can take anywhere from hours to months or to even be identified. And a statement we use quite regularly is called fat fingers or inadvertent errors, which can make network offline. So this is the data we gather from bgpstream.com, which is now Cisco, owned by Cisco now. Into 2020, BGP Stream collectors around the world identified more than 2,000 events termed as possible hijacks. You can see two high rises. These are very well-known incidents. And if you look at the BGP leaks in 2020, most of the year they were not that many. Of course, looking at the size of the BGP or the routing table at the moment, you can consider this as not that many. But there were a few high rises as compared to the whole year. If you combine them both, you can literally see there were incidents on every day from BGP leaks or the BGP hijack. And if you come check it with 2019 incidents and 2020 incidents, well, things are not getting better. Yes, 2030 incident doesn't make a lot of impact if they are not propagated globally, or if it's just a one prefix or two prefix, but the incident happens, which shows that there are networks in the middle of the internet that not doing the route filtering properly. So this is a typical route hijack looks like. I am old enough to remember the most famous 2008 YouTube hijack done by the Pakistan Telecom. I think that was the time when everybody realized that now we have to fix it. And now things have changed, but still not everything has changed. So let's talk about the inadvertent errors, or in our technical terms, we call it fat fingers errors most of the time. These are just the human errors. You're trying to type something and accidentally you have typed something different, right? And it happens all the time. It's not that it is intentional, of course it's not, but we can avoid them by doing few things. We'll discuss that at the end, but let's talk about the incidents first. So, for example, a network operator wanted to do BGP prepend, AS prepend, and their AS number was 59356. Well, in a hurry, they were trying to type something, and they typed in 59365 once and then 59355 once. Both of them were accepted by the command, and there's nothing wrong with the command. For them, for the BGP, it is just a number. They are not intelligently looking at what AS you own, so they are just gonna put those numbers in and start announcing the prefixes alongside your OS number and the prepend you are trying to do. Same as the case is on the right side is 37129 is your AS number, and then you started doing 7 as the AS prepend. On the left side, it makes a lot of sense that somebody actually did a mistake. But on the right side, well, it doesn't make any sense. 37129 and then 7 as the AS prepend is is not a very intentional mistake or unintentional mistake. So that was a bit strange for me. Anyway, like every network operator or a network engineer, I shared these things on the Twitter. And our very own friend Doug Midori raised a very valid point at that time, that where this is very common for a single-digit AS number, and he pointed out towards a very old blog post from 2013 by Anurag, saying he did mention that about the single-digit AS number, and that triggered a I would say a rabbit hole for me, that I started looking at the data since 2013, that how much problem exists with single-digit AS number. So I didn't go further up to 2018 because I was looking at the data. I said, like, that's too much information. Let's stick to a couple of years. So in 2018, 19, 20, and of course the remaining of the 2020, I looked up BGP streaming data and see if the single digit or 1 to 10 AS number were present in the announcement or the origin of any announcement. Of course, they do announce some prefixes, but you can literally see if it's been used as AS prepend or not. So you can see the numbers, it's growing. Well, the size of the round table is growing. The number of networks we are adding, like around 3,000 every year or something. So of course, it's growing quite rapidly, so as the number of incidents. If you look at the spread of AS1 to 10 in 2018, they were all over the place. AS2 was the biggest, AS7 and 6 were the next, and AS3. So these are the AS number originating the prefixes they are not supposed to, right? So apparently, these AS numbers were hijacking prefixes. They were not, and I'll explain to you why they were not. So these are the numbers again. The prefixes, the AS number in the middle are the legitimate owner or the custodian of the prefixes they were announcing, but all of a sudden AS1 or AS2 started originating these prefixes. Of course, but they were still propagating through the original AS number. So this is from 2019. All of a sudden, AS 1, 2, 3, 4, 1, 2, 3, 5 are now the dominant ones, and AS 10 are still there. You can see at the end there are some again some unique numbers, which clearly shows that these are the lab announcements which leaked out to the internet, because of course once you connect your lab environment to the live internet, it will go out somehow. So you can see there are other numbers as well, but we are focusing right now at the AS number between 1 to 10. Again, these are the cases here. AS 11113, 11112 were detected. These are very common AS number which you might have used in your lab. So if you are doing it still, well, there is a big chunk of private AS number, you can use them. Or if you still want to use these imaginary AS number, just remember they are allocated, most likely they are allocated to somebody else, or if they are free, still they are considered as hijack. Now, again, moving into other unique AS number, these are, if you look at this one, expected AS number was 2, 3 times 0, and then 2, 2. And then whoever was doing the AS prepend, they did 2, 4 times 0, and 2, 2. Again, this is a very, I would consider is a very genuine mistake, right? Not the other one. Like if you are doing that many times 111, then of course it is coming from your lab. And as the AS name suggests, that is, it's experimental computing facility in the US, so definitely they were doing some experimentation. Moving forward into 2020, you can see the AS1 and AS2 are now increasing. So there are 12 incidents recorded by BGP stream, or each for AS1 and AS2, and for AS5 there are a number of 8. Well, you can see that while doing the AS prepend, most of the time people do at least one AS prepend or twice. So that's why it is showing up in this list of incidents. Sometimes people do AS prepend 10 times. Well, there is another research by Doug Midori who looked into the length of the AS prepend, and it's extraordinary how many times people prepend just to do the traffic engineering. So again, the list is going wide and broad in terms of what people are using in terms of prepend. This case is quite unique, right? So in a very small period of time, you can check the data from the right RIS, the screenshot are from there, that 135171 started prepending with 1, then with 2, with 4, and then ultimately with 10. Apparently, whatever they were doing was not working because they were doing it incorrectly. That's why it was not working. So you can have a look at that. At the end, they actually managed to fix it. Here you can see they started prepending it properly. So if we count it, it's like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So they managed to do it like this for traffic engineering for sure. Again, if you calculate the total number from 2018 to 2021, AS2 and AS1 are the dominant ones, and AS5 again is there as well. So, and I looked up this information on 12th of April, and you can go and use the regular expression on BGP and see for all AS numbers starting from 1 to 10 and see who's announcing what. So you can see AS1 is announcing all these prefixes. They are not supposed to. And then you can also have a look at AS2, so on and so forth for all other AS numbers. So if you look at this number, you'll see that why they are announcing them, and it's of course most likely these prefixes are gone, but you will see other prefixes and by other AS number as their peers. But if the problem is not going away, the problem is still exists, and as of today, that's what I'm trying to say. And it is we need to understand why this is happening. So here is the reason why it is happening. That is my strong belief that this is why it is happening. I would say allegedly, it's because I cannot prove it that all the incident happened in the last 3, 4, 5, 10 years, but because of this. So we all use a very nice product called MikroTik. The routing operating system they use is Router OS, right? And they use, of course, they provide, they have a very strong BGP implementation, and while offering the BGP, they offer you two things, which is AS path prepend. But there are two ways you can do AS path prepend using Router OS. Number one is you can set BGP prepend, which is how many times to prepend router's own AS number. If my AS number is 139.038, which is my AS number anyway, it is asking me how many times to prepend router's own AS number. So this is a number, right? So as it explains in the in their command reference, that it is an integer they are expecting. That how many times you want to add your own AS number. So if I set 2, it means they will add my AS number along with my original announcement. So this is still my AS number. Now, the second command is set BGP prepend dash path. Now, this is the problem. Add a specified list of AS number to the AS path. If both set BGP prepend and set BGP prepend path are used, then the first one will get the highest priority. So what is happening is, most likely, network engineers are using the second command, which is prepend path, while using the integer value of the first command. So if I say set BGP prepend path and give 1, expecting that it will add 1 to it will add my AS number one more time, it will not. It will add 1 as the AS path origin. And this is where I believe, and allegedly, that the problem exists. It is just lack of understanding, I would say, or just not looking at the details at how these two commands are implemented. And I wouldn't blame people, because if you look at the syntax, it's very, very same. So what should we call it? It's just an AS prepend hijack, microtik prepend hijack, or something else, or it's just a configuration mistake, which is causing these problems to the global routing table. And you just saw that it's still happening. So it's not like that it used to happen and now we have fixed it magically. It's not. So a couple of lessons, right? Filtering AS number is as important as prefix filtering. So we put a lot of emphasis on, you should filter your customers, right? Your downstream customers all the time, that it is for the network operators or the internet service providers, that you should always filter prefixes, right? But a lot of network operators, and the reason why you can see all these propagations is because network operators are not filtering the AS numbers. And that's why the AS numbers are propagating all across the global routing table. And the second lesson I would say should be for all of us is create filters before configuring neighbors. You don't start your configuration as if it is not a live network. So it is a live network. Don't go ahead and start doing the configuration. Make sure that put the filters in place first before you do anything. Practice with regular expression. Of course, it's complicated. It's boring, to be fair, but it helps you understand a lot of problems. Try to avoid unnecessary prepend. There are other ways you can do traffic engineering. You don't have to rely on the AS prepend only. Test in the lab environment. You don't have to necessarily start doing it on the live network as well. For example, if you have done the router OS testing in the lab, you must have learned that there is a problem. Talk to other members of the community for help. If you're using a new routing operating system, they probably can help you with this. The data shows how easy it is to hijack an AS number and remain undetected. So if any detection mechanism you're using, what they're going to say is AS1 has hijacked these prefixes, or AS2 has hijacked these prefixes. AS1 and AS2 has actually no idea that they are hijacking anything, because they are not. It is the other AS number which just made a mistake and now announcing these prefixes with a wrong origin. But if you combine this with a ASN plus prefix hijacks, it will make ROA, which is route origin authorization, useless. The reason is that now you have, because what RPK, but what ROA tells you that who is the rightful owner or the custodian of this prefix. You already have the AS number. You just have to start announcing the prefix of those AS numbers. And then you have a perfect hijack with a perfect ROA. So this is a big problem. It can be a big problem. And we have seen it a couple of times. So we have to make sure that we are not only filtering on the basis of ROAS, which is route origin validation, we also doing the traditional filterings. For example, looking at what the customer, your downstream customer, are able to announce in terms of prefix as well as AS number. Once you have that in place alongside the route origin validation, then we can say we are doing our best to protect the routing table. And as part of the manners initiative, this is what we recommend. We tell you that do the filtering as well as the global validation. So if you combine them both, then it will help secure the routing we rely on for the internet. If you look at the details in the manners action, you'll find all the implementation guide as well. We have updated the implementation guide recently, and it also includes microtick. So if you have, if you want to look at it, please go onto the manners.org website, and you can get all the details. Here's the link for the implementation guide, just in case you are interested. We also have a manners lab, which also include microtick. So you can test it. If you don't have a lab, you can test it on our lab, and we can help you with that as well. So this is all I wanted to discuss. If you have any questions, I'm more than happy to answer them.
Aftab, great presentation. Thanks for joining us for the this QA. And this is a really good summary of all the incidents here in the last few years with route advertisements and some of those autonomous systems showing up. The first question we have is, you at the very end, you recommended references like manners and best practices. For a service provider, what would be the first step towards helping with the cases you described here? What would be the first steps an operator should take?
Yeah, thank you for having me. The most important thing for a service provider is just the one term we learned early in the year, starting as a network engineer, was never trust your customers. So treat your own network as your own customer at times, if it isn't segmented in a way. So make sure that you filter out anything which is not supposed to be on the internet, which is not supposed to be on the routing table. So first thing, just look up your own routing table. That what are you announcing to the world? Is it the right prefixes? Is it is it originating from the right AS number? So just look it up and make sure that you are not announcing anything which was not supposed to be. And for that, as I mentioned on the presentation, that we do have an implementation guide on the website, but not just that, NANOG, which is the Netherlands NOG, they do have very nice BGP filtering primer on their website. You can have a look. They have filters available for all major routing OSs, in microtick included, but you can test it with some of them and see what is the outcome of those filters. So most important thing I would say is just have a look at what you are advertising first, and then start going from there. Make sure you have the filters in place.
Okay, very good. And I think you mentioned earlier that you make sure you have filters for the AS numbers that you're learning. That would be an easy step.
Sorry, you dropped for a second. So.
Yes, earlier you were talking about filtering on AS numbers. That is definitely a recommendation at this point.
Yes, absolutely. So what we have seen quite regularly, even those who are very strict with the prefix filtering, they do not implement the AS filter. And I would say it is important that this part is also important. Yes, prefix filtering is much more important, of course, because we have seen the route hijacks because of that. But AS filtering is also important. So just make sure whenever you are putting filters in place, you do not omit the AS filters, so that it is as important as the prefix.
Got it. Thank you. Another question is, what other methods to replace BGPS path prepending for inbound internet traffic engineering are available?
I mean, the one people are using quite often is the deaggregation. I think we are at the stage where we do not discriminate deaggregation anymore. I think we have stopped it quite long ago. So you may use that if that can help. What we have seen, I remember Doug Midori did a research paper quite a long time, not so long ago, where he actually measured the actual path of the AS prepend, that how many times people are trying to prepend. And there are some astonishing numbers, huge. I have no idea what that yields. Of course, whatever they are trying to do is not helping them. So that's why they keep on adding prepend. So if that's not working for you, you can deaggregate. I don't think so. It's a frowned upon practice anymore.
Okay. Were you, another question, were you able to, in your analysis, were you able to differentiate between, talking about the single digit AS numbers, there are entities out there that are advertising those and they have the right to do that. Were you able to separate that from the ones that were advertising them and they were not authorized to do that? Were you able to separate that data?
Absolutely. So in the result I have put up on the slides, I only used, I reference checked anything which they were, so it's the single digit, because some single digits do announce prefixes. It's not like that they are not doing anything on the global route table. So they do announce it. So I removed those which were the legitimate announcement. I only kept the illegitimate announcements. So just looked up the IRR tables. It's easy to look it up. Yeah, so that's what I did.
Okay, very good. Aftab, appreciate you joining us again, presenting and joining this Q&A.